Hello everyone, this is Heading Tian. In this lecture, let's learn Chapter 8.4, Vectors. We are going to learn six objectives. The first one, let's learn vector and magnitude. Scalars are quantities that are described by a single value called magnitude. What's the meaning of magnitude? That's just a single value, like 5 meters or 5 feet or 5 miles. So that's just a single values. It doesn't have the direction. And vectors are the quantities that are described by both magnitude. That means they need to have the single values and the directions. That means the velocity is one example. For example, the velocity has two parts. One part is the speed. For example, I have 50 miles per hour. This is the magnitude part. And then I said, I'm going to the east. So this two parts satisfied. That means this one is a vector. The velocity is a vector. It has the magnitude part and also has the direction part. And one thing, if I'm driving my car at Houston to the east and my speed, so my velocity, for example, v sub 1, and my velocity is 50 miles per hour. I'm driving to the east, and you are driving your car at New York. You're driving 50 miles per hour and also to the east. This is your speed. So do we have the same velocity? Of course, because we have the same speed, same magnitude part, and also have the same direction. Even we are in different position. I'm here, you are in New York, but we still have the same velocity. Okay, let's move on to see the vector. We always use the lowercase u, v, w, or some other lowercase letters like r something to represent the vectors. So the vector v can also be represented as a, b. A is an initial point, b is terminal point. So for example, I have a point A is here, B is here. So A to B, for example, B is here. A to B means a vector is starting from A and end at B. So there is a arrow on the top of AB. Okay, for example, vector V from 0, 0 to -4, 2. So this is the point A. And this is point B. So the V is starting from A to B. So find the A and B on the image, on the XY plane. So 0, 0 is A. And then -4, 2 is the B. So the vector is from here pointing to this point. So the V is starting from here to here. The blue arrow is the vector V. And how about the vector W? W is from 1, 3. Find the 1, 3. And then going to -3, 5. So the pink arrow is the vector W. And the part A is looking for the magnitude of V and the magnitude of W. The magnitude we have learned that's a scalar. And in the xy plane, the magnitude of a vector, that's the distance between these 2 points. We have learned how to find the distance between 2 points. So number A, the magnitude, we use this. So like a double absolute value, sign. So we said this one is magnitude of v equals the distance between these 2 points. Is that means x2 minus x1 squared plus y2 minus y1 squared? Yes. So plug in y1 and y2. So the b is the x2, y2. So -4 minus 0 is -4 squared, because minus 0 minus nothing, plus y minus 0, y2 minus 0, that's 2 squared. So this one equals 16 plus 4 is 20. So this one is 2 times square root of 5. And also they're asking about the magnitude of W. It's still using the same formula. So this one is the formula, right? So use x2 minus x1 squared plus y2 minus y1 squared. So -3 minus 1 squared plus 5 minus 3 squared. So this is a 4 squared. This is 2 squared. That's square root of 20 equals 2 square root of 5. So they have the same magnitude. How about the direction? Do they have the same direction? Actually, I mentioned about in previous example. That means if they have the same magnitude and then they are going to the same direction, that means they are same vector. So for example, the first vector v from the initial to the terminal, this is angle theta. And then we draw the vertical line and horizontal line here. This one, we can say this is theta 2. This is theta 1. If theta 2 and theta 1 has the same value, that means these two vectors are the same. So how to find theta 1 and theta 2? So we have learned that tangent, for example, theta 1 equals b over a, or I say x or y over x is better, right? So put y over x here. So what is the y for the vector v, the blue one? So the y is the distance from here to here. That's 2, right? Or you use x2, oh, sorry, y2 minus y1. So that's 2. 2 minus 0. And x is from here to here, right? That's -4 minus 0. That's -4 minus 0 is just a -4. So this one is -1/2. Another tangent theta 2. It still equals y over x. So the y's value is between here to here, right? We can use y2 minus y1. y2 is 5, y1 is 3. So 5 minus 3 is 2. How about the x? The x is -3 minus 1. -3 minus 1, is that equals 2 over -4? Is that -1/2? Yes, they have the same slope. So if they have the same slope, that means they are the same. So yes, v equals w, because we have satisfied the two conditions for the vector. First, the first, the magnitude, they are the same. Second, the direction, they are the same, because we are using the slope y over x to find the tangent theta 1 and theta 2. They are the same. It means the two angles, they are the same. If two angles, they are the same, they have the same direction. So V equals W. So we solved this one. Let's move on to second part, the component form. AB is called component form of a vector if vector is V. So V equals AB. It seems like the point AB, but they are same. The symbol is vector. So what's the meaning of AB? So if I have a vector V and the A is the projection of the V on the x-axis, and the B is a projection of the V on the y-axis, this direction. So why, if I use AB, I can represent the V, the vector V? Because do you remember the V, the magnitude of V equals A squared plus B squared, because this is the right triangle. So the magnitude of V equals square root of A squared plus B squared. So if A, B, they are fixed, that means the velocity is, the magnitude of the velocity or this vector is fixed. So satisfy the first condition. Second, how about the direction? So tangent, for example, this theta. Tangent theta equals B over A. If B and A, they are fixed, that means the angle is fixed. That means the direction is fixed. So satisfy two conditions. That means this one, we can use this form, the component form, to represent the vector V. Okay, let's move on to see this. Okay, component form of a vector. Let P is the starting point, x1, y1, and the Q is terminal point or end point is x2, y2. So be points in the plane, and let V is PQ. The component form of V is given by, okay, if I know 2 points, so I can find the component form of the vector V by using the x2 minus x1, that's the A part, and the y2 minus y1, that's the B part. So that's the length from here to here, from here to here. And then this is the length from here to here. So let's see some examples. Next one, standard position, initial point at the origin 0, 0. If I said the V is at the standard position, that means the starting point is 0, 0. So the distance from here, from the A, go back to 0, that's the A. From here to here is the B. So the V equals x2 minus 0 or minus x1, comma, y2 minus y1, because y1 and y2 they are 0, 0. So this one can be represented by x2, y2. We have known that A, B are y2 and x2 are in the y2. So this one is A, B. Okay, let's move on to the example. The vector V has an initial point -2, 1, and terminal point 2, -5. Find the component form of V. So the component form A equals, so x2 minus x1, that's 2 minus -2, comma, y2 minus y1, -5 minus 1 equals 4, -6. So this is a component form of the vector v. Okay, number B, sketch v in standard position. So if we have the v like this, the standard position is starting at the 0, so the end point is 4, -6. So number B, I can sketch it here. So find the point 4, -6. It's better to draw the picture like this. For example, this is 4, this is -6. So the point is here. The point is here. Fix it. Too long. For example, the point is here. So this is a vector v. It's starting from 0, 0 to 4, -6. And number C, sketch v with its initial point at 2, 3. So that means the initial is not 0. So based on this point, and then we add the vector v on this, and then find the end point. So let's see. So the new starting point is not 0, 0, is 2 and 3. So 2 add 4. And then 3 add -6. This one is 6, -3. What's the meaning of that? So for the C, so if I have this one, and starting point is 2, 3. For example, this is 2, this is 3. Okay, it's here. And then I need to move this this vector, for example, before the vector is here. I need to move this vector to here, and then the vector become like this. So how to move this to the position starting from here and then the same direction, same magnitude? Just add the vector based on the initial point 2 and 3. So at 2, you need to plus the 4, and then at the point 3, you need to add -6. Okay, next one, operations. So if v is a1, b1, and w is a2, b2, then v equals w if and only if a1 equals a2, b1 equals b2. That means if I have two vectors, they are the same. So a part, they are same, and the b part, they must be the same. So let's see next part. Operations on vectors. Operations on vectors. So let v equals a sub 1, b sub 1, w equals a sub 2, b sub 2, and c be a real number. So c, I can say c is a scalar. Vector addition, if I add v and w together, so a1 plus a2, add the a part together, and then b1, b1 plus b2, add the b part together. If v minus w, that equals a1 minus a2, subtract the a part, And then b1 minus b2, subtract the b part. Multiplication of vector by scalar. So c is a scalar, c times the v. That means just distribute the c. So this one's skip one step because c times the scalar a1 b1, and that means I can distribute the c to the a1 and b1. So we get this one. Let's see the example. V equals 2, 3, W equals 4, 5. Find W plus, find the V plus W. This one is easy. Add the A part together. 2 plus 4. And then 3 plus 5 equals 6, 8. And then second, V minus W. So V minus W, 2 minus 4, 3 minus 5. That's negative 2, negative 2. Okay, this one is easy one. So how to sketch it? How to sketch V plus W? We have two methods. The first method, we do the tip to tail. So if we have two vectors randomly, for example, we have V like this and W like this. This is V, this is W. The first step by using the tip to tail, that means I need to move one vector here. So move the W to here. So after moving it here, I change it to the red color. So the W, oh, sorry. The W I moved to here, and they have the same, this one have the same magnitude and the same direction. And the V and W, they are tip. This is a tip. And then to the W's tail. So we say this one is tip to tail. Let me draw the V again. For example, this is a V. So the tip to the tail, the tip of the V pointed to the tail of the W. So when we move them together and then we use a line, let's say this one is pretty. So from the tail to the tip, or I can say from initial point to this terminal point. So the purple one is V plus W because we do the tip to tail, and then the sum is from here to here. That means the sum is tip to tip because this is tip to tip and tail to tail. So this image shows you that if I add V and W together, the sum of V and W is from this point, the P point to the R point. Because look at here, the P is is tail to tail, and then the R point is tip to tip. Okay, another method, placing V and W tail to tail. So if I have these two, so if I erase this one and I erase this W because they are on the plane randomly. So if I need to move W and V together by tail to tail, that means the W need to be placed here. And let the W and V have the tail to tail. And then next step, draw a parallelogram. So how to draw a parallelogram? If I use this one, I can draw a parallelogram. Parallel to this one, and then parallel to this one. And then diagonal is the sum. So the diagonal, if I use this pretty color, the diagonal is the sum of W and V. So you can use two methods. The first method is tip to tail, and then the sum V plus W is tip to tip and tail to tail. The second method is move the V and W to the tail to tail version, and then the sum is the diagonal of the parallelogram. So you can use two methods. So if I erase this one, you can see the method from the graph. So the second one, you move W and V together as a tail to tail form, and then draw a parallelogram. And then this one is the diagonal is a sum. That's the V plus W. So we have two methods. So how about V minus W? If I have two, I can also use two methods to find V minus W. So we have V here and W here. So if by the first method, that's tip to tail, I need to move them together. And we mentioned about the addition, V plus W, but we know that V minus W equals V plus negative W. That means negative W is the opposite direction of the W. So I can move them together, just change the distance of the W. So keep the V. For example, this is V. And then W, I know this is W because I can move the W here. But we know we need to add the opposite of the W. So the W is the opposite direction. I change to the red color, represent W. The same magnitude, but different position. So this is negative W. So I can erase the W. And then, so the sum of V and negative W, what is that? The sum of these two is that tip to tip, tail to tail. Yes. So let me move this V here. So the sum of V plus negative W is from here to here, is tail to tail, tip to tip. So we find V minus W. How about the second method? So how about the tail to tail method? So that means I can move this W to this place. Oh. So this place, make sure they have same position. Oh, same direction. So I can move this W to here. So make sure V and W has the same starting point, or the tail heat to each other. So when I let them be together. So for example, this is V, this is W. So for how to find V minus W? So before we have learned we can draw a parallelogram like this. And then there's a V plus W. How about the V minus W? V minus W, we first also draw a parallelogram and then line up another diagonal starting from the tip of W and end at the tip of the V. So let me use a red color. So this one is V minus W. So some student asking me why. So we have learned, for example, let this one equals R. So the red one is the R. So can I move the W to another side equals, so V equals R plus W. So if V is R plus W, let's see W and this red line, arrow, that's R. So W is tip to the tail of the R. So W plus R, is that equals V? V is tail to tail, tip to tip. Yes, that means if V minus W, you first draw a parallelogram and then starting from the W, because minus W, starting from the W, point to the tip of the V. So this is the way we find the subtraction. Okay. Okay, that's perfect. So remember, if we do the tail to tail, and then how to find the subtraction, we just starting from the W, the number, we do the subtraction. So from W to the tip of the V. So we can use the two method. So this one and this one, they are the same, even they have different position, but they are pointing to the same direction and they have the same magnitude. So let's move on to see next example. Let's use black color. Given V is 1, 4 and W is 3, -2, find V plus W. So it's very easy, but how to sketch it? So if we find the value of V plus W, that's 1 plus 3 is 4. And 4 plus -2 is is 2. And then how about V minus W? V minus W is 1 minus 3 is -2. 4 minus -2 is 6. So how to sketch it? Sorry. If we start a V and W, they are from the standard position. That means the starting point is 0, 0. So the starting point is here. And then for the V, it's from here to 1, 4 is here. And then W is 3, -2. So it's from initial 0, 0 to the point here. And we are looking for the addition. That means we can draw a parallelogram because this is tail to tail. So after drawing the parallelogram and line up the diagonal, so the pink line, the pink one, that's the sum, V plus W. How about subtraction? So this is tail to tail. Do you still remember if we do the tail to tail and then the result is starting from the tip of W because we minus W and then pointing to the V, this diagonal is the subtraction. Okay, so this is the way how we find V plus W and V minus W. Okay, let's see. This one, it doesn't say let you to sketch it, but we can sketch it later. So K is 2, V is 3, 5. Find the KW. So distribute the K. So K, oh, not W, that's KV. KV equals 6, because 2 times 3 is 6, 2 times 5 is 10. So this is the KV. So how about let's sketch it on the standard position. So for the V, before in the example, in the question they gave us is 3, 5. So 3, 5, so make it smaller, 3 and 5. So the point is from initial to this point, 3, 5. And then K times V, so becomes 6, 10. So 6, because this is 3. So I can say this is 6. This is 3, this is 6, this is 5. This is 10. So this vector is stretched, but the position didn't change because the K is greater than 0. So the K keep the same direction with the vector V. And then K is greater than 1. That means we stretch it. If it's less than 1, like 0.5, so shrink the vector. So let's continue. Next one, given R is -3, 8, and S is 2, -5. Find A is 5R. So A 5 times R is -3, 8 equals -15 and 40. Number B is 2R minus 3X. What is 2R? 2R equals -6, 16. What is 3S? 3S is 6, -15. So 2R minus 3S equals, so -6 minus 6 is -12, and 16 minus 15 is 31. So -12 and 31. Okay, let's see the property of vectors. If U, V, and W are vectors, and C and D are scalars, then the first one, V plus W equals W plus V. Second, V plus W plus U equals V plus W plus U. So you can do these two first, or you can do these two first. And number 3, V plus 0 is V. And number 4, V plus -V is 0. Number 5, C times V plus W, we can do the distribution. So equals CV plus CW. Number 6, C plus D times V equals CV plus DV. We distribute the V. And then number 7, C times D, two scalars, times V equals C times DV. Next one, 1 times V is V. Number 9, 0 times V is 0. Number 10, C times 0 is 0. Number 11, the magnitude of CV equals C, the absolute value of C times V. So the C is a scalar. So the magnitude of a scalar is absolute value of C. So for example, C is scalar, the speed is scalar, like 5 mile per hour. So the magnitude, the length or magnitude of the 5 miles per hour, that's the absolute value of 50. That's just 50. If I say here is the ground, and then something is under the ground, the height is 20 meters. 20 meters. That means the 20 is not positive because above the ground, this one is 20 meters. That's positive. So under the ground, that's negative 20. So this one is negative 20. But I'm looking for the magnitude. Magnitude of C, magnitude of negative 20. That's just the absolute value of 20. That's 20 because I'm looking for the magnitude, just the length of this, the scalar of this, not the direction. Okay, let's see. Let's continue to see represent vectors in terms of I and J. A vector that has magnitude of 1 unit is called a unit vector. Here is the definition of unit vector. That means the magnitude of 1 unit is called unit vector. So if I have a vector AB, how to find the unit vector of the V? We say the unit vector of V is U sub V. The direction of V is given. So since they have the AB, that means the direction is all set. The first step, we need to find the magnitude of the V and use 1 over magnitude, this part, times the V. So when we do this step, we got the solution equals A over magnitude of V, B over magnitude of V. And then the magnitude of this is 1. You can check the why the magnitude of the unit vector is 1. So let's see. So V, we have learned the magnitude of V equals square root of A squared plus B squared. So if I found to find the unit vector's magnitude, U sub V, that equals square root of the A over magnitude of V squared plus B over magnitude of V squared. This one equals A squared plus B squared, and the magnitude of V squared. And then we have learned that the bottom one is is A squared plus B squared. The top is A squared plus B squared is 1. That means the magnitude of a unit vector, that's 1. So we can use this expression to represent any unit vector of the vector V. Okay, let's see the example. If you don't understand how I do this, it's okay. You just memorize the formula here to find the unit vector. Okay, let's see. Find the unit vector in the direction of W equals -3, 2. So first step to find the magnitude of W. The magnitude of W equals square root of A squared plus B squared. And -3 squared plus 2 squared. That's 9 squared plus 4. Oh, sorry. That's 9 square root of 9 plus 4. That's square root of 13. 13. Okay, so the U sub W equals 1 over the magnitude of W times -3, 2, and plug in the square root of 3 in it, equals 1 over square root of 13 times -3, 2, and we can distribute that. That equals -3 over square root of 13, 2 over square root of 13. Okay, next one. I equals 1, 0, and j equals 0, 1. These two are special unit vector because their magnitude is 1. And then why they are special? If we draw the plane. So where is, in the standard position, where is I, where is j? I is 1, 0, is here, from initial 0, 0 to here. And then j is from initial to here. This is I, this is j. So they are standard, they are very special in standard position. One is on the x-plane, x-axis. One is on the y-axis. So how to represent all kind of vectors in the form of I and j? So if I have vector v equals a, b, by the property of vectors, can I split it into two parts? That equals a, 0 plus 0b. Because a and 0 add together is a. 0 plus b is b. And then can I pull out the a? A times 1, 0 plus b times 0, 1. So the first part is that 1 is I, is that ai, and then this is j plus bj. That means any kind of a vector AB can be written like V equals AI plus BJ. The value A and B are called scalar horizontal and vertical components of V, respectively. Okay, write the vectors in terms of I and j. So this one, number A is very easy because we know that equals negative 3i plus 5j. That's it. And then number B is a little bit difficult because you need to do some computations. First, find 3w. 3 times w equals 6.2 times 3 is 18.6i, and then minus 3 times 3.4j. That's 10.2j, and minus 5w. So 5v. Sorry, 5v equals 5. 1.7 times 5. That's 8.5 I, and minus 2.2 times 5. 11j. Is that correct? If no mistake. So 3w minus v, 5v. So remember, we need to do the I part together and V part together. That means the I part is 18.6 minus another I is 8.5 I. And then plus this one, this I is negative 10.2. Oh, another part is J part. Then minus negative 11j. So this one is 10.1 I plus, so let's see, what are these? So 11 minus 10.2, 0.8j. So this is the answer. Yeah, this is the answer. Let me erase this part. Let's move on to see related component. Let's see related component form and direction and magnitude of a vector. So let V equals AB be a vector in standard position, and the theta is between 0 degrees to 360 degrees, be the direction of V measured counterclockwise from positive x-axis. So look at these. This is the magnitude of V. So from the initial 0, 0 to the endpoint AB. Okay, if let's see the relationship between the magnitude and the point AB. The magnitude of V equals square root of A squared plus B squared, and tangent theta equals B over A. And A is not 0, 0. And the A, how to find the A? So the A is from the initial to here, right? So that's the A. And we have learned if I do the cosine, so cosine theta equals A over the magnitude of V. So if I'm looking for the A equals magnitude of V times cosine theta, and B is the same, equals the magnitude of V times sine theta. So if we have A and B, do you still remember V equals AB? And write it into the I and J form is AI plus BJ. Plus BJ. So that equals the magnitude of V times cosine theta I plus magnitude of V times sine theta J. So the V can be represented by this. If the given information is the magnitude of V and the theta. So let's see next example. Given the F, the magnitude of F, F is a vector. Actually, sometimes F represents the force. It has the magnitude and also has the direction. So F is 100 pounds. Theta is 315 degrees. Write the vector of F in the form of F equals AI plus BJ. Since it doesn't have information of A and B, but we know the magnitude of F and the theta. And then we can find the F into the terms of I and J. So the F, the theta is 315. So from initial to here, that's the theta is going to this direction. And the F, the distance from here to here is 100 pounds. So the F equals the magnitude of F times cosine theta I plus magnitude of F times sine theta J. And then it's 100. Plug in the numbers. 100 times cosine 315 degrees I plus 100 times sine 315 degrees J. So what is the cosine 315? It's in the fourth quadrant, ASTC. So here is positive. So positive reference angle is pi over 4 or 45 degrees. So 100 times square root 2 over 2I plus, so 100 times sine 315 degrees. So it's in the fourth quadrant, sine is negative. So it's 100 times sine, negative sine 45 degrees. So 100 times negative square root 2 over 2 J. And then simplify this is 50 square root 2i plus minus, because it's minus here. Okay, 50 square root 2. So this is a final form. Okay, let's move on to see next example. A ball is thrown at the time of release. The velocity of the ball is given by this. It gives you the form of the v in terms of ij, where each component is given in meter per second. Find the initial velocity v sub 0. V sub 0 is the magnitude of the velocity vector at the time of release, and the angle above the horizontal at which the ball has thrown round to 1 decimal place. Oh, it's looking for the magnitude of V and also looking for the theta. Let's use the relationship. So the magnitude of V equals square root of a squared plus b squared. So a is 22.6 plus b squared is 8.2 squared. Let's use the calculator to find the value. Let's see. Okay. Square root, quick second squared, that's the square root. 22.6 squared plus 8.2 squared. And then hit enter. That's about 24.0. So I can say that's 24 because keep 1 decimals. That's about 24 and 0.0 meter per second. This is the magnitude of V. And then find the theta. We know that tangent theta equals B over A. B over A. B is 8.2. A is 22.6. Let's see. Tangent, inverse tangent theta equals inverse tangent 8.2 over 22.6. Let's see what is the degree, what is the angle of this vector. So second tangent 8.2 divided by 22.6 and then hit enter. So remember your the calculator must be in the degree mode. So 19.9, that's about 19.9 degrees. So we found all the solution. So the ball was thrown with an initial velocity of 24.0 meter per second at an angle of 19.9 degrees above the horizontal. Okay, next one, a lot of application, a lot of questions. The first example, a ship is open ocean travels 18 miles per hour at a bearing of north 64 degrees west and encounter a current of 4 miles per hour acting on the direction of north 45 degrees east, rounding to 1 decimal place. So by the given information, we can draw the image. So let's see. The blue one is the V, is the ship traveling 18 miles per hour, and then the bearing is from here to here is 64, and then it encounters the current of 4 miles per hour. So if the ship within the silent water or there's no current, So the ship is going to this direction, but there is a current. So the current speed is going to this direction. It's going to this 4 miles per hour. So the ship has the new speed or the new velocity. It can't go this way because the current doesn't let it to go straight. Then the ship must go as the velocity of v plus the currents. So the new velocity r equals c plus v or v plus c. It doesn't matter. If I say v plus c, so let's see the picture. So the picture give you the information. So the v is tip to tail. So the sum of v and c is from here to here. That's tail to tail, tip to tip, tail to tip, tail, tip to tips. Okay. Let's read the question because maybe we just miss some miss to solve the first and the second question. So first one, express the velocity of a ship v relative to the water in the term of I and j. So the v can be represented in the term of I and g by the magnitude of v times cosine theta I plus magnitude of v times sine theta I. What is the theta? So look at this. They gave you the bearing is 64. But we know the theta is starting from the initial point, initial line, from here to here. So the 64 need to be added by the 90 degrees. So the magnitude of v is 18 is given. 18 times cosine. So 64 degrees plus 90 degrees. I plus 18 sine 64 degrees plus 90 degrees J. So use the calculator to find what are they. So 19 times cosine 64 plus 90, close the parentheses. Let's see. It's a negative 16.2. This is I. Let's see, what is the J? Um, 18 times sine 64 plus 90. Let's see, hit enter. So that's 7.9. 7.9 J. This is the A. How about the B? B is looking for the C. C equals the magnitude of C times cosine. The theta for C, theta I plus absolute, oh no, that's magnitude of C times sine theta J. What is the theta for the current? So the current is here. So this one is the bearing is 45 degrees. How about from the initial to the terminal? Looking for this. See. Looking for this one because from initial to that's 90 minus 45, right? So I can just put so C times cosine 90 degrees minus 45 degrees I plus magnitude of C sine 90 degrees minus 45 degrees J. And then C is 4. So 4 times cosine 45 is square root 2 over 2 I plus 4 times square root 2 over 2 J. That's 2 square root 2 I plus 2 times square root 2 J. So this is A and B. How about the C? I have no space. So let's see, read the question. What are we looking for part C? So part C, find the true speed and the bearing of the ship. We are looking for the magnitude of R and the bearing. Oh, true speed, because speed has no direction. So we are looking for the magnitude of R and the bearing. So we don't know the bearing. Bearing for the R is from here to here. How to find the angle here? If we can find the R, so we can find the theta from initial to here. So use theta minus 90 degrees, we can find the bearing, right? So number C, part C. Let me write it down like here. So part C. So C equals V plus C. Oh, sorry, R. We are looking for R. So add the C, V and C together. That means add the I part together and the J part together. That's negative 16.2 plus 2 square root 2I and then plus J part is negative positive 7.9 plus 2 square root 2J. So simplify this one. So let's see. Negative 16.2 plus 2 times square root 2, or just the 2 square root 2. Second squared 1. Hit enter to see what is that. So negative 13.4. Negative 13.4. Goodness. I, and then plus, let's see. So 7.9 plus 2 times 2 square root 2. Hit enter is 10.7. 10.7J. So the magnitude of R equals square root of negative 13.4 squared plus 10.7 squared. That's about square root of negative 13.4 squared plus 10.7 squared. Then hit enter. That's 17.1. 17.1. So how about the theta? Theta, so tangent theta equals B over A. So B is 10.7, A is negative 13.4. And this is a negative angle. So they only gave us the calculator give us the angle for inverse tangent is here and here. So it's in the first quadrant. So can I find the, if I have more space, I'd like to, so let me move this one. Okay. So first plug in the number in it. So 10.7 over negative 13.4. That's negative 0.7985. And then we know the theta, if we want to find the inverse of tangent, we will get a negative angle. If we get a negative angle, so if I move it to here, if we got a negative angle like this, so how to find the theta? Theta is not this negative angle, but we have learned this angle, the reference of this angle equals this. That means I can only find the tangent, inverse tangent, 0.7985. Because here is negative, I can find the positive value of this. Then I know the reference angle of this one. Reference angle equals this one. That means I found this one. Then I can find the theta. If you don't want to find theta, because we are only looking for the bearing, we are only looking for this one, because this is the bearing we are looking for. That means if we have the reference angle, use 90 degrees minus the reference angle, we can find the bearing of the arc. So let's find this first, and then we will know this is a reference angle. Then we can find the bearing of the arc. So let's use a calculator to find tangent, inverse tangent 0.7985. Let's use a calculator. So second tangent 0.7985. This is 38.6. Okay, we are looking for the bearing. Use 90 degrees minus this angle. So the angle, let's say this is alpha. Alpha. So alpha equals 90 degrees minus inverse tangent 0.7985. So the alpha is about 90 minus 38.6. That's 51.4. So we found all three solutions for this question. Okay, let's move on to next example. Joe enters a triathlon and must swim to a buoy offshore and then back again. A current of 0.6 mile per hour flows due west. So the picture draw the information from the question. Okay, so Joe is starting from the J point, and then he wants to get to the position B, but the current doesn't like the Joe to swim like this, because the current is the water is moving to this direction. So if Joe is swimming like this, so the sum of these two vectors will make the draw arrive this point, not the point B. That means the draw must swing to this direction, and then plus the currents, plus the current, so he can move straight and then arrive the point B. So in the graph, so in this graph, the V is draw is swimming the direction the draw is swimming, and then C is the current as it flows due west. It's going to this direction. Let's see. The question A, if Joe starts as the closest point J on the shoreline to the buoy B, in what direction theta is looking for the theta should be swim in order to arrive at the buoy? Assume that Joe's speed swimming in still water is 2 miles per hour. Round to the nearest tenth of the degree. It's looking for theta. We can figure out the relationship between these three vectors. So we have three vectors. The first one is the V as the velocity of Joe swimming is going to this direction, right? And then the velocity of current, and then the sum of V and the C. So let's list the relationship between these three vectors. So So if the sum of the vector C and V is R, so R equals V plus C. And look at the image. The R is just to have the J direction. It's the R is going to this way. It's not like this, so it has the X and Y direction. It only not have the I and J direction. It's only have the J direction. So I don't know what is the what is the K. So I can just say R is 0 times I, because no I direction, plus the K. Yes, I don't know what is a K, just at least a variance K there. J equals V. What is the V? So we have learned the V is going to this direction. So the V equals the magnitude of V times cosine theta I plus the magnitude of V times sine theta J. This is the V. And then plus the C. C is magnitude of C times cosine. So C, what is the angle of C? Can I draw vertical line and horizontal line? So from the initial to the terminal, the angle is 180. So it's given is 180 as I. And then plus the magnitude of C times sine 180 degrees J. And this one is so V, the speed of Joe is 2, is given 2 times cosine theta. Okay, so remember you can add the I part together. So let's add the I part together. Plus the magnitude of C is 0.6. 0.6 times cosine 180. Cosine 180 is -1, so negative 0.6. This is I. and then the j part plus the j part 2 times sine theta, 2 sine theta. And then this one is 0.2 times sine 180. So sine 180 is 0. That means this part is 0. Plus 0 is just a plus nothing, j. And we have learned the I part is 0. That means 2 times cosine theta minus 0.6 equals 0. That means cosine theta equals 0.3 because isolate the cosine. And the theta equals the inverse of cosine 0.3. And then let's use calculator to find what is inverse cosine 0.3. It's 72.5 degrees. So we know the theta. So this is the question A looking for. So what is the B? What's the Joule's true speed? If we know, we can find the R, and then the true speed of Joule is the magnitude of R. How to find the magnitude of R? Since we already know the theta, so the R equals 0I plus K J, and then equals, so plug in theta's value in it, because first part is 0, I plus 2 times sine 72.5 J. So we can find the K. Or we don't need to find the K, because if we have this part, we can find the magnitude of R. 0 squared plus 2 sine 72.5 degrees. It's just squared, just this part. So let's see, what are these? So 2 times sine 72.5 close parentheses. That's 1.9. And then remember, this is the speed. So we have the unit, that's miles per hour. Okay, last question. 2 cranes support a 3,000 pound crate create equilibrium as shown in the figure. Find the magnitude of the tension vectors T1 and T2. Run to the nearest pond. So look at this graph. What's the relationship of them? So I can simplify this graph into this. So just 1 point. And then all the force balanced really well. So one force is T1. And then let's draw the vertical line and horizontal line. Another one is T2. And all the angles are given 30 degrees, 60 degrees. And then another force is going down, is W equals negative 3,000 J. Because this is pointing to the down, is pointing down, that means it's negative 3,000 J. It's only have the J direction, it doesn't have I direction. That means all the force balanced well. So the T2 plus T1 has the force like this direction. So if I draw the the parallelogram. We'll have this. So this one. So this vector must be equal to this vector. So this one, I need to make it longer. So it's going to this direction. 3000 J. So that means T2 plus T1 on the J direction, that's 3000. And then on the I direction, they balance the force to each other. So this J equals this J. And so this I direction equal this I direction. And the J direction, the sum of the J direction is 3000 J. Let's list the relationship with each other. Sorry. So actually, let's list the vector T1, T2. So T1 equals the magnitude of T1 times cosine, the angle. So what is the angle for T1? Is this one? The 60 degrees I plus the magnitude of T1 times sine 60 J. How about T2? T2 is the magnitude of T2 times cosine with the angle. So from initial to T2, that's 90 plus 60. That's 150 degrees I plus magnitude of T sub 2 times sine 150 degrees J. And then we have learned on the J direction, the sum must be 3000 J, and then it can balance the negative 3000 J. So we can list two equations. The first equation, we can do the J direction first, because T1 plus T2 balance the J directions, negative 3000. So the sum of the J direction is 3000 J. So absolute, the magnitude of T1 times sine 60 degrees J plus the magnitude of T2 times sine 150 degrees J equals 3000 J. And then how about the I direction? Since they need to balance to each other. So this direction and this direction had the same, so the sum must be 0. That means the I direction's sum is 0. The magnitude of T1 times cosine 60 degrees I plus the T2 times sine. Oh, sorry, it's cosine. Cosine 150. Cosine 150 degrees on the I direction is 0, because they need to balance to each other. So the sum of them is 0. So we have two equations. So T1 times, so sine 60 degrees is square root of 3/2. And then another terms is that's 1/2, because sine 150 degrees is 1/2. 1/2 the magnitude of T2 equals times J equals 3000. So if I divided by J, all of these three terms is 3000. And then plug in the cosine 60 and cosine 150. That's what is cosine 60 is 1/2. 1/2 times absolute value, magnitude of T1 plus the cosine. Cosine in second quadrant is negative. So minus square root of 3 over 2. And then times the magnitude of T2. And then equals 0. And then let's solve. From the second one is easier because its right hand side is 0. So I can multiply by 2 all of them and move this term, second term, to the right hand side. So by 2, number 2. So we have the magnitude of T1 equals square root of 3 magnitude of T2. So I can plug in this one into the first one. So T1 is square root of 3 times magnitude of T2. So it's square root of 3. I think I have no space. Can I write it down here? So let me copy that by 2. And then magnitude of T1 equals square root of 3 times magnitude of T2. And then plug it into 1. Okay. Erase this part. So as magnitude of T1 times, oh no. So we replace the magnitude of T1 here. The square root of 3 magnitude of T2 times square root of 3 over 2 plus 1/2 square root of 1/2 times the magnitude of T2 equals 3,000. And then we can add these two terms together. That's 1/2. 3 square root of 3 times square root of 3, that's 3. So 3 plus 1 is 4. 4 over 2 is 2. 2 magnitude of T2 is 3,000. So magnitude of T2 equals 1,500. 1,500, not 1,000. So the unit is pound. How about the magnitude of T1? So we know the relationship between T1, T2. So the magnitude of T1 equals square root of 3 times 1,500. So that's about what? Let's see the calculator. So square root of 3 times 1,500. That's 2598. 2598.1 if it's let us keep 1 decimal places. So the unit is pound. Let's see. Oh, the question asks us round to the nearest pound. So we can't keep the 1 here. So I can omit the 1. So here is a solution for the magnitude of T1 and T2. Okay, that's all about this class, this lesson. If you have any question, please let me know. Have a good one.